Hey guys, welcome in. Sorry I'm not here today for 7th hour. I had to go to a doctor's appointment with my wife for our baby that's on the way in June, and she wanted me to check in with her and go to that appointment. So Gulick is here in class. If you have questions, she was here 4th hour, working through my 4th hour pre-algebra class, so she can answer any questions you guys have. The idea is to take the notes for today over scatter plots and association, so looking at some data analysis with this unit, and then work on your worksheet for your homework, your assignment. So kind of take the time here to go through these notes with me, the first page of your packet, and then you'll have whatever time's left after that to work on your homework assignment. All right, guys, so when we think about scatter plots, those are things you've seen before, but it's literally like it sounds. You're just scattering your data, points plotted all over the coordinate grid, kind of represents two different variables. So we're still looking at numerical data, so numbered data, right, or numbered values here, but we're within two variables. So we call that bivariate data. It's like it sounds. Bi meaning two, variate meaning variations, or two different types of variables that we're looking at. Scatter plots can help determine if one variable has an effect on the other, if there are any overall trends, patterns, or what we call associations, okay? Associations between the variables. So we're really looking at, is there a relationship between the two variables? And we'll see some examples where there's strong relationships that are positive, or even negative relationships that are strong. We'll see some that are weak positive relationships and weak negative relationships and strong negative relationships. We'll also see some that have no association within our variable parts as well, okay? So as we look at Susie here, she's the first example. We're kind of working through this and seeing this firsthand here, right? Susie went to the mall and she surveyed shoppers to see how many items they purchased and the total amount of money they spent at the mall. So items purchased, right? And then total amount of money are our two spent, are our two variables. Total amount of money is going to be the y in this example. Number of items is going to be your x. So the first question they want us to answer is, how many shoppers did Susie survey? Well, if we're looking at the number of shoppers in a scatter plot, your points represent your data values. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points here. So there's 16 shoppers. So we're thinking each dot represents a value or a point in this graph. And so each shopper there is represented by the 16 dots, okay? And then it says, does the number of items purchased seem to have an effect? That's the biggest thing, have an effect on the amount of money the shoppers spent. So if you guys look over time here, over the number of items, right? If I look at my X and look at my Y, it seems as though we have a trend and it looks like it's going up, right? As the total amount of money spent increases, so does the number of items, right? So for the most part, so mostly is what we can say, the more items purchased, right, which is your X value, items purchased, my X's, right, the higher, we can fill in the blank here, higher total cost, which is my Y, okay? And this is what we call a positive relationship, because if I were to draw a line, which we're going to do a lot more here in just a minute, if I were to draw a line, it's a positive relationship, right? It's going up. As one increases, so does the other. We have these few that are kind of off to the side here, which are some outliers, which we'll talk a little bit more about as we go. But for the most part, the rest of these are pretty close together on that line. And so we can say, in general, mostly, right, the trend is a positive trend because the total spent is going up or increasing as the number of items increases as well. All right, guys, this next section is probably the most important in terms of how we start to describe our associations and our relationships between data within these scatter plots. So a positive association, that's when two variables, again, remember, bivariate data, so two variables, they have a positive association when variables move together. So what do we mean by that? If we look at this graph, this is kind of like the last one we looked at. As one increases, so does the other. So for example, if one variable increases, the other, or the second variable, also increases in a positive association. One's going up, so is the other, so we have that positive example. A negative association is the opposite of that, right? So if two variables, again, a negative association when variables move in opposite directions this time, okay? So in this case, as one gets bigger, as my x's get bigger, right, my y's get smaller, right? So for example, if one variable is increasing, like the x's are here, the other one decreases, okay? Decreases, if I spell that right, make sure I do that. And we want to make sure that that's shown in both examples, right? As one's going up, the other one's going down. So we can flip-flop our variables in that part. But if one's increasing, right, like the x's are getting bigger here and the other one's decreasing, you can see that negative trend. It's going downward in a downward direction. The last one is our no association, right? They have no association when one variable has no effect on the second variable. So the important thing here is looking at your variable pieces and understanding, if there's no relationship. So for example, I've been using in some of the other classes, the number of pieces of pizza you ate last night and the number of pairs of shoes you have. Probably no real relation there, right? Just because you have more shoes doesn't mean you're eating more pieces of pizza, or more shoes meaning less pieces of pizza. So there's really no relation, no true effect from one variable to the other in that example. So if we see something like this where they're literally all scattered about, there's no real trend, whether it's going in a positive or negative direction, it's just kind of everywhere, that's when you see a no association. So if we look at these next three examples and kind of determine which one is which, it says describe each of the type of association. One's a positive example, one's a negative example, and one is a no association example. So the hours a person studies is one, and then the number of states they visited, okay? In general, the hours a person studies, states they visited. That's probably a no association. In general, there's really no relationship or effect between the two of those. Just because a person studies a bunch doesn't mean they're going to a bunch of different states, okay? Or vice versa, those kind of things. So this one really is a no association because there's really no relationship between the two of them, okay? If I look at B, this is a little bit different. The hour a person studies and they're graded on the exam. For the most part, right, and this is really important too, don't talk yourself into this. Don't come up with crazy scenarios. Read it just like it says. The hours a person studies and they're graded on the exam, that's technically, or generally, more of a positive relationship because the more you study, a lot of times, the better your grade is on the exam. I know there's times where it's different, right? You could study a whole bunch and still not do very well, or maybe study very little and still do very well, that kind of thing. But in general, if a person studies more, just in general, when we think about it, the better their grade is probably going to be on some sort of assessment or exam. So that means the last one here, the hours a person studies and the hours they spend watching TV, is your negative example. And this could go either way. If I spend more time studying, that's less time watching TV. So one's going up, the other one's going down. Or if I spend less time studying, chances are I might be spending more time watching TV. So again, they're going in opposite directions. When it's opposite directions, it's negative. When they're going in the same direction, whether it's both increasing or both decreasing, that's a positive association. So again, just another way of kind of looking at descriptions and answering that. All right, pause this video. Make sure you've got everything the way that you need to for that first page before we move on to the second page. All right, so as we continue to go through these scatter plots, the next thing we want to think about is trends and how that looks in the form of the shape of your plotted points, right? So if a straight line can be drawn, to follow the trend of the overall scatter plot, it is said to be linear. And a lot of the models we've dealt with this year have been linear. So just for example, okay, pretty linear model here for this first one. So we're going to end up, and we'll do this here in a minute for all 6 of these, we're going to end up with 3 ways to describe this. One of them is either linear or nonlinear. This is a linear example because if I draw a straight line, and I could have even maybe lowered it a little bit on the graph. If I draw a straight line and it can follow that overall general trend, then it's going to be a linear model, okay? If the points of the data are close together, another way to describe that would be a strong relationship. So you'll notice in this example, we've got a pretty strong relationship because those data points are really close together. So it's linear, right? And it's pretty straight line, and it's close together, so that's a strong example. If the points of the data are widely spread, right? If they're not close together or widely spread, the opposite of strong would be weak, okay? And so we'll see some examples like that. So here's what we're going to do down here. I'm going to do the first 2 with you guys. I'm going to have you pause the video, try 3, 4, 5, and 6, and then watch it again. We're going to label each type of association. So we're going to go positive or negative, right, to start. And this one we can already go ahead and say positive. So there's the first one. Positive because it's going increasing for both, right? Strong because they're close together. And then linear, right? So we're going to talk about the strength, either strong or weak is another way to describe it. So that's our second term we're going to use. And then whether or not it's linear or not. So linear, or we'll say non-linear in these examples. And we'll show a little bit of what that looks like too, okay? So for example, we look at number 2. If I have the 3 things I'm looking at here, 1, 2, 3. The first thing I'm asking myself, is it positive or negative? Or no association, because that could be possible too. But this is going in a positive direction. As one increases, the other one's increasing. So I'm going to draw a line here kind of like this, right? So as one goes up, the other one's going up. So I'll also say this one's positive. But what I notice about this one compared to the first one, right, there's less dots and they're not as close together. I'd say they're more widely spread. So I'm going to go ahead and say a weak association here. And the reason for that, again, is they're not as many that are close together, right? They aren't as close together. There's not as many. So that's a weak, but it's still linear in shape because I can still draw that straight line that follows the overall trend of the scatter plot, okay? Actually, I'm going to do number 3 with you guys too really quick just so you can see this one, and then I'll let you do the last 3 on your own by pausing the video, okay? So this one, if I draw a line that kind of works its way through my points here, okay? Again, it's going in a positive direction. We kind of start at a steady, but then we jump up really quick. So as I'm increasing, just in general, as I'm increasing here, I'm also increasing there. So we'll still say positive for this one, okay? I would go ahead and say this is strong because the dots, again, are really close to one another. There's not a lot of space in between them. But what you'll notice, right, in this one, we kind of go steady and then we jump up really quick. That's not a true straight line graph. So this one is actually a non-linear, positive, strong example. Dots are close together, follows that positive trend, one increasing and so is the other one, but it's non-linear in terms of its model because of the way it looks. All right, so based on those first 3, I want you to try 4, 5, and 6. Remember, you're going to come up with 3 different descriptors for each one: positive or negative first, strong or weak second, and then linear or non-linear third. So try these 3 on your own and then unpause the video and look at it again. All right, I hope you took the time to do this on your own for these last 3, okay? So look at number 4 first. Again, we see that these are close together, so we got a strong relationship, and there is a straight line that can kind of go through and follow the trend. But this time, as one increases, the x's increase, the y's go down, so that's why we get a negative. So negative, strong, linear for number 4. Number 5, as one's increasing, so as the x's increase again, the y's are going down, so it's a negative example. But you'll notice these points are not as close together. They're not quite as many. So we're going to go ahead and call it weak, and we'll say non-linear. And the reason it's non-linear is because of that little curve that happens here, right? We go down pretty quick, and we kind of just plateau or even out there. So it's a curved line that goes through most of those points, so that's your non-linear. Number 6 is your big one here, right? There's really no association, no positive or negative. If that's the case, you're automatically going to be weak and nonlinear because there's a weak association since they're not close together. They're all scattered about, and there's no true line that we could draw here, which would be nonlinear, okay? So then the last part has you look at a table and looks at a few more graphs and how we're describing this. We're going to talk about type of association, so we're just thinking positive or negative here and the reasons why, okay? So on number 7, the first one, a person's height and a person's shoe size. So if you think about this, as the height goes up a lot of times, right? So does the shoe size. So think about that. If one's increasing, the other's increasing, that's going to be a positive example. Okay? And I know, again, don't talk yourself out of this. I know that there's some people that have smaller shoe sizes, but they're taller, or they may be smaller with bigger shoe size. But in general, for the most part, when we look at this, right, we're going to have a taller person with a bigger shoe size. Okay? Person's IQ and the number of letters in a person's name. Okay? So let's think about this. My name's Cam, right? A lot of people call me Cam or Cameron, but that's a short name, right? That doesn't necessarily mean that I am not as smart or that I am smarter. There's really no association with this one, okay? When you think about a person's name, their letters, and then you think about their IQ, this would be a graph that's scattered all about, okay? Just because your name's 20 letters long doesn't mean you're going to be smarter than somebody with a 3-letter name, or vice versa, that kind of thing. So this one's really a no association. This would be a graph, if you looked at it, right, that would have dots all over the place and not be a true association that we go through, all right? So no association there between those two. So then you probably guessed that this last one's probably going to be the other, which makes sense. The number of absences a student has and their GPA is negative, and here's why, okay? You could look at it 2 ways. If you're absent more, if your absences go up, that probably means your GPA is going to go down because you're going to be late on things, not getting stuff turned in, not understanding assignments. Or you could look at the other way, right? If you're absent less time, your GPA is probably going to, in most part, go up because that means you're going to be here, you're going to turn things in, you're going to understand the content in class. And so either way, you look at it, it's negative because one's going up, the other one's going down. More absences, lower GPA. Less absences, higher GPA for the most part. So that's why that one's negative. Okay? And then our last one here, when we take a look at this, it looks at matching each scatter plot with its possible description. So what I would tell you, if you look at 8, 9, and 10, this is more of a negative association. Okay, a negative association. This one looks more positive, okay? And then this one looks more like a no association type graph. So that might help you when you decide which one of these is representing which, okay? So look at letter A. It says the temperature outside and the total gallons of gas sold at a gas station. If the temperature goes up, does that necessarily mean that the people buying gas goes up? Not necessarily. And same thing if it goes down, right? That it wouldn't. And I wouldn't say it's negative. I wouldn't say that the temperature goes up, less people buy gas, and if the temperature goes down, more. So this one is probably your example with no association. People are going to buy gas no matter what, right? Depending on the temperature, depending on the weather, depends on what they drive, how much they drive, that kind of thing. So that's your no association graph. So I would go with letter A, going with 10. That's your no association graph when you're looking at that one, okay? If we look at B, it says the size of the home and the cost of monthly utilities. Utilities means things like internet, water, heat, electric, that kind of thing. So the size of your home, if that goes up a lot of times, you're probably going to spend more money on utilities because it takes more to heat the house, or you might need a couple different routers for your internet, or you may use more water because you have 4 bathrooms in the kitchen instead of 2 bathrooms in the kitchen, that kind of thing. So this would be more of your positive example. So we're going to go with B as number 9 because, again, the size of the home goes up. A lot of times your monthly utilities go up. So that means our last one here, right? The altitude of a hiker and the total oxygen in the air. The higher you go up as a hiker, the less air there is to breathe. That's why it's harder to breathe, less oxygen. So we're going to go with letter C for number 8, because the higher the altitude, right? X is your altitude, the lower the oxygen. So if this was your oxygen, right? And this was your altitude when you look at it, that's what's happening there, right? The higher the altitude, the less oxygen there, okay? So just a couple things to think about and remind yourself about as you work through this, all right? What I'll tell you guys is you'll have a worksheet assignment that looks very similar to these notes. So make sure you're taking your time to go through that and answer those questions and get that done for your homework tonight. Tomorrow we can go over anything that you need to in terms of what that looks like and if you have any questions, all right? Thanks for getting your work done. Again, sorry for not being here. Just had to make sure I ducked out for that doctor's appointment with my wife. So shoot me an email if you have questions. Otherwise, I will catch you again tomorrow in class. Thanks for your hard work, guys.